In this third lecture, we will talk about advantages and disadvantages of finite difference method. The reason of talking about these advantages and disadvantages of finite difference method is that we want to justify why we want to use the finite volume method. We want to study finite volume method. So let me just give you a brief introduction, a brief overview of advantages of finite difference method. When you are going to start or to learn a numerical method, the first choice is to apply or use finite difference method in your study, since it is very easy to use. So this is one of the advantages of finite difference method. The second advantage is, or I should write it as a first advantage, you simply apply difference formulas, difference formulas on PDEs or ODEs. This is a kind of advantage, since you don't need to convert your ODE or your PDE into any other form like we do in finite element method or finite volume method. For example, we can apply forward difference method, forward difference formula, or backward difference formula, or central difference formula. This one is the first advantage. The second one is it is very easy to implement in softwares like MATLAB or Python. Either you use 1D problem or 2D problem. It can be easily apply to 1D, 2D, and 3D. The extension from 1D to 2D is very straightforward, and same is the case with from 2D to 3D. Then we have one of the other advantages, it requires low memory of computers, since it is very straightforward. Parallel computing in FDM is straightforward. You don't need to put a lot of effort in writing your code first in the form of in parallelized code, a difficult way. There is no difficult way to write a code in parallelized form in FDM. So it is also straightforward. As I mentioned earlier, the finite difference method is a first choice of any person who wants to study numerical method. So there are tutorials available. Tutorials are available online, and books and other notes are available online. So these are the advantages of finite difference method. Now we move to disadvantages of finite difference method. The problem is when we have a complex geometry, then we can apply, but it is very difficult to use finite difference method for complex geometry. Complex geometry may be a kind of irregular geometry, is a kind of irregular geometry or curved geometry. In such situations, finite difference method is not a very popular choice. The next one is it suffers stability issues. Since different parameters appear when we discretize the partial differential equation or ordinary differential equation, those parameters decides the solution, and those solutions can be unstable or stable. It depends on the parameter. For example, if we have a advection equation that we will talk about in future, partial u by partial x is equal to 0. When we discretize this problem, and we will discretize this in future, we get a CFL number which looks like this: a delta t over delta x. And when this CFL number is less than or equal to 1, then the solution is stable. If it is CFL is greater than or equal to 1, then the solution is unstable. So it suffers a stability issues. Then there is a very big disadvantage of finite difference method when we have discontinuous solution. When we have discontinuous solution, we cannot apply FDM. Since FDM, finite difference method, is based on Taylor series, and Taylor series requires that the function should be continuous and differentiable. But for discontinuous solution, we cannot write this in the Taylor series form, so we cannot use finite difference method. So these are the few disadvantages of finite difference method, and one of the biggest disadvantages is the discontinuous solution. So in this video, we only talked about advantages and disadvantages of finite difference method. Thank you for watching.